March 6, 1944. 8th Air Force Headquarters, England. The Mission Briefing Room. Chalk scraped across blackboard as weather officers marked wind speeds and cloud formations over Berlin. Target, Reich Air Ministry. Expected opposition, severe. Colonel Hubert Zemke studied the tactical map and reached for the secure telephone. 48 Republic P-47 Thunderbolts would escort the bomber stream. The 56th Fighter Group, the 61st Squadron, the 62nd Squadron. What none of them knew was that this single mission would demonstrate the most devastating combination of survivability and firepower in aerial combat history. The European Air War had taught American forces that fighters were not just weapons of attack. They were shields. Break those shields and entire bomber formations would perish. The Luftwaffe's Jagdgeschwader 2 and Jagdgeschwader 26 had established defensive sectors stretching from the Channel coast to Berlin. Elite squadrons positioned to intercept any American penetration of German airspace. Messerschmitt Bf-109s and Focke-Wulf FW-190s flown by experten with years of combat experience. The P-47 Thunderbolt roared through English skies at 350 miles per hour, its massive frame displacing more air than any single-engine fighter ever built. 8 tons of armour, ammunition and engineering. Lieutenant Robert Johnson stood on the wing studying his aircraft's battle damage from the previous mission. His fighter carried armour plating behind the pilot, self-sealing fuel tanks, and an arsenal specifically designed to destroy anything in its path. 8 Browning M 2.50 caliber machine guns, each capable of firing 800 rounds per minute. 5-inch high-velocity rockets mounted under reinforced wings and suspended beneath the fuselage. The component that would make aviation history, a Pratt and Whitney R2800 double Wasp radial engine producing 2,000 horsepower. The R2800 represented American engineering at its most robust. Unlike liquid-cooled engines that failed with a single coolant leak, the radial engine could lose entire cylinders and continue running. Each of the 18 cylinders displaced 155.7 cubic inches. The mathematics were brutal. German 20mm cannon shells that would destroy a Messerschmitt's cooling system merely damaged individual cylinders on the Thunderbolt. The P-47 achieved survival rates that seemed impossible. Traditional fighters lost in combat at rates exceeding 10% per mission. The Thunderbolt lost 0.7%. Executive Officer Gerald Johnson had studied those statistics until they were burned into his memory. West Point educated with a mind for tactical analysis and mechanical systems. Johnson understood that aerial combat was ultimately about energy management, altitude converting to speed at 32 feet per second squared, target tracking calculations, deflection shooting. The difference between a hit and a miss often came down to understanding physics and exploiting mechanical advantages. Aboard Focke-Wulf FW-190A-5, Black 3, Oberstleutnant Egon Meyer reviewed his ammunition loadout. 2 MG-151/20 cannons with 250 rounds each. 2 MG-17 machine guns with 1,000 rounds each. Armour-piercing and high-explosive shells mixed in precise ratios. 102 previous victories had taught him that American bombers required specific attack angles and ammunition management, but the new escort fighters presented different challenges. Intelligence reports described the P-47 as heavily armoured, difficult to destroy, requiring concentrated fire to critical components. Meyer had developed the head-on attack technique against B-17 formations. 4 to 5 20mm hits would destroy a bomber from the frontal aspect. 20 hits required from other angles. The mathematics of destruction calculated through 3 years of combat experience, but the P-47s absorbed damage that defied those calculations. Pilots returned with aircraft containing over 200 bullet holes, engines missing cylinders, control surfaces shredded, wings punctured by cannon shells. The American formations assembled over East Anglia. 3 squadron strength search patterns as they climbed toward escort altitude. USS George equivalent formations to port, USS Rabbi equivalent formations to starboard, the 56th Fighter Group in the center. Each Thunderbolt swept the sky with Mark IV gun sights and carefully calibrated weapon systems. The pilots worked in 4 ship flights, their training refined through months of combat. Stop every few degrees, check blind spots, scan for contrails. The weather was clear, conditions ideal for long-range visual acquisition. Temperature minus 40 degrees Fahrenheit at altitude. Contrails inevitable above 25,000 feet. At 9:15 on March 6th, Johnson's flight spotted the enemy formation. 16 Focke-Wulf 190s climbing from the east, bearing 090 degrees relative. He pressed the radio transmit button and adjusted his gun switches. Bandits, 3 o'clock high, 16 plus closing fast. In Meyer's cockpit, the fighter controller's voice crackled through the radio. Achtung, Indianer approaching section Anton Bertha. Heavy escorts accompanying bomber stream. Meyer ordered an immediate combat climb. Full throttle, emergency boost engaged. The BMW 801 radial engine screamed as methanol water injection increased power to 2,100 horsepower. Climb rate 3,300 feet per minute. Time to combat altitude 4 minutes and 30 seconds. Executive Officer Gerald Johnson plotted the intercept geometry on his knee pad. Enemy speed estimated at 350 miles per hour. Closure rate approximately 600 miles per hour. Altitude advantage currently 2,000 feet to the Germans. The Thunderbolt's critical altitude was 30,000 feet, where the turbo supercharger gave maximum advantage, but engagement would occur at 27,000 feet, where both aircraft types performed effectively. The first engagement came at 0923. 8 P-47s dove from 29,000 feet in a carefully calculated bounce designed to convert altitude into speed and surprise. The Thunderbolts accelerated past 450 miles per hour in their dive. Armor-piercing incendiary tracers streaked through the morning sky. No hits on the initial pass. Clean miss. The Germans had broken at the exact moment, using their superior roll rate to evade. Gerald Johnson adjusted his calculations. The enemy reaction time was faster than expected, probably 2 seconds from visual acquisition to evasive action. He ordered a different approach angle and prepared for the second attack. At 9:31, the second bounce scored multiple hits. Concentrated fire from 4 Thunderbolts hammered a Focke-Wulf's engine cowling. Black smoke trailed from the damaged fighter, but the pilot retained control. Johnson could see the German fighter's propeller still turning, the aircraft still maneuverable despite obvious damage. The BMW 801 radial engine proving nearly as robust as the American R-2800. The third attack came at 9:35. Johnson had calculated the deflection angle at 30 degrees, but wind drift at altitude affected bullet trajectories. The streaming fire passed behind the target. Meyer's wingman had executed a defensive barrel roll at the precise moment, using the Focke-Wulf's superior roll rate of 160 degrees per second. Standard evasion tactics that had kept Luftwaffe pilots alive throughout the defensive campaign. The fourth attack succeeded when Lieutenant Walter Beckham caught a Focke-Wulf in a climbing turn. 8 machine guns concentrated on the enemy fighter for a 3-second burst. 400 rounds of .50 caliber ammunition hammered the German aircraft. The Focke-Wulf's wing route failed. The aircraft entered an unrecoverable spin. No parachute observed. At 9:42, Meyer led his swarm in a head-on attack against Johnson's flight. Closing speed over 600 miles per hour. Time in effective gun range less than 2 seconds. Both formations opened fire at 800 yards. Tracers crisscrossed in the morning sky. Johnson's P-47 shuddered as 20mm cannon shells struck home. 3 hits in the engine cowling, 2 hits in the right wing, 1 hit in the tail section, oil pressure dropping, cylinder head temperature rising, but the engine continued running. The massive R-2800 double Wasp had absorbed damage that would have destroyed any other fighter. 2 cylinders were damaged, compression lost, but 16 cylinders continued firing. Oil leaked from punctured lines, but redundant systems maintained pressure. The turbocharger, protected by armour plating and mounted in the rear fuselage, remained undamaged. Johnson reduced power to 75% and turned for home. 20 minutes later, Johnson landed at Halesworth. Ground crews counted 43 bullet holes and 5 cannon strikes. The aircraft would fly again after 2 days of repairs. The pilot was uninjured. The mission had demonstrated the fundamental truth of the P-47's design philosophy: survivability through redundancy, power through excess capacity, victory through mechanical superiority. But the broader tactical implications were just beginning to emerge. On June 26, 1943, the 56th Fighter Group had encountered Jagdgeschwader 26 over France. 48 Thunderbolts against 16 Focke-Wulfs. The mathematics seemed to favour the Americans, but experience and position gave the Germans critical advantages. What followed would become the most famous demonstration of P-47 survivability in aviation history. Lieutenant Robert Johnson flew as tail-end Charlie in the 61st Squadron formation, the most vulnerable position assigned to newer pilots as part of their combat education. His P-47C-2-RE, serial number 41-6235, carried the name Half Pint on its cowling. Standard armament of 8.50 caliber machine guns with 350 rounds per gun. The formation flew at 26,000 feet, approaching Forges-les-Eaux when German fighters struck from above and behind. The first indication of attack came from exploding ammunition. 21 20mm cannon shells ripped through Johnson's fuselage in the first 2 seconds. The instrument panel exploded. The canopy shattered. Hydraulic fluid sprayed into the cockpit. A cannon shell fragment sliced across Johnson's nose. Machine gun bullets punctured the oxygen system. Fire erupted behind the engine cowling as fuel lines ruptured. Johnson's P-47 rolled inverted and entered a spin. Centrifugal force pressed him against the canopy. The altimeter unwound through 20,000 feet, 15,000 feet, 10,000 feet. Standard recovery procedure: opposite rudder, forward stick, neutral ailerons. No response. The fire spread along the fuselage. Ammunition began cooking off in the wing magazines. At 4,000 feet, the fire suddenly extinguished. Fuel starvation or oxygen depletion at lower altitude. The spin stopped. Johnson regained marginal control. The canopy release mechanism had been destroyed by cannon fire. The plexiglass was partially melted, trapping Johnson inside. Manual escape impossible. The engine ran rough, missing on multiple cylinders, but maintained power. Oil covered the forward windscreen. Forward visibility 0. Peripheral vision limited to gaps in the shattered side panels. Navigation by magnetic compass impossible, the instrument destroyed. Johnson turned west toward the channel, flying by instinct and sun position. Altitude 1,000 feet. Airspeed unknown, the indicator destroyed. Engine temperature unknown, gauges shattered. Fuel quantity unknown, though fuel leaked steadily from multiple punctures. The English Channel lay 50 miles distant. German territory below. Anti-aircraft positions along the coast. Fighter bases at Abbeville and Poix. The probability of reaching England seemed minimal. Then Johnson spotted the worst possible sight. A Focke-Wulf FW-190 approaching from behind. Blue and yellow nose marking. The aircraft of an expertise. Johnson was defenceless. His gun sight was destroyed. Hydraulic pressure 0, meaning no gun charging capability even if the weapons functioned. Speed approximately 200 miles per hour, barely above stalling. The German fighter positioned for the killing shot. The FW-190 opened fire at 300 yards. Machine gun bullets hammered Johnson's P-47. The sound was overwhelming, metal shrieking as bullets punched through aluminum. The armor plate behind Johnson's seat rang like a bell as rounds struck it repeatedly. Fabric shredded, control cables frayed. The instrument panel, already destroyed, disintegrated further. Johnson hunched forward, making himself as small as possible behind the armor plate. The German pilot, later identified in some accounts as Egon Meyer, though this remains disputed, fired precise bursts. Professional, methodical shooting. The FW-190's ammunition loadout included 1,000 rounds of 7.92mm for the machine guns. The 20mm cannons had apparently been expended in earlier combat. For 3 minutes, the German fighter methodically pumped bullets into the crippled Thunderbolt. Short bursts to conserve ammunition, aimed shots at critical components, engine cowling, wing roots, control surfaces, fuel tanks. Johnson's P-47 absorbed the punishment and continued flying. The R2800 engine, despite running on 14 cylinders, maintained power. The control surfaces, though shredded, still responded to input. The self-sealing fuel tanks, though punctured multiple times, prevented catastrophic fuel loss. The German pilot pulled alongside Johnson's aircraft. Through the shattered canopy, Johnson could see the enemy pilot examining the Thunderbolt. The German shook his head in apparent disbelief. No aircraft should still be flying after absorbing such damage. The FW-190 dropped back for another attack run. More machine gun fire raked the Thunderbolt. Bullets walked across the wings, fuselage and tail section. The elevator trim tabs were shot away. The rudder was holed repeatedly. The ailerons were punctured. Still, the P-47 flew. The German pilot pulled alongside again. He appeared to be out of ammunition or had given up trying to destroy the seemingly indestructible American fighter. The German pilot looked directly at Johnson, rocked his wings in what might have been a salute, then turned back toward France. Johnson crossed the English Channel at 500 feet altitude, the engine running rougher, power fading, oil pressure near zero. The English coast appeared through the oil-smeared windscreen. RAF Manston lay 10 miles inland. Johnson had no radio, no instruments, no way to signal his condition. He approached the field at minimum altitude, hoping someone would recognize an aircraft in distress. The landing was more controlled crash than landing. No flaps, hydraulics destroyed, no brakes for the same reason. The main gear, locked down by emergency extension, held. The Thunderbolt rolled the entire length of the runway before grinding to a stop. Fire crews and medical personnel surrounded the aircraft. They could not open the canopy. Cannon damage had jammed the mechanism permanently. They used fire axes to chop through the plexiglass. Johnson climbed out, covered in hydraulic fluid, blood from minor wounds and oil. He walked around his aircraft and attempted to count the bullet holes. He stopped counting at 200 on just one side of the fuselage. Later, analysis revealed at least 21 20mm cannon strikes and over 200 machine gun bullet holes. One cannon shell had passed through the armor plate behind Johnson's seat without detonating, leaving a perfect 20mm hole, half an inch to either side, and Johnson would have been killed. The aircraft, half pint, was written off as destroyed, irreparable. But Johnson flew again 4 days later in a new P-47. He would eventually score 27 aerial victories, becoming one of America's highest-scoring aces in Europe. His survival on June 26, 1943, became legendary among P-47 pilots, proof that their aircraft could absorb damage beyond rational calculation and still bring them home. The psychological impact on Luftwaffe pilots was significant. Intelligence reports intercepted by Allied monitoring stations revealed growing concern among German pilots about American superfighters that seemed impossible to destroy. The term Betonflugzeug, concrete aircraft, appeared in German pilot reports. Luftwaffe training manuals were revised to emphasize attacking P-47s only with concentrated 20mm cannon fire aimed at specific vulnerable points: the turbo supercharger intake, the oil cooler, the cockpit. But even these tactics proved marginally effective. Captain Fred Christensen of the 62nd Squadron survived 47 bullet holes and 6 20mm cannon strikes on July 29, 1943. Lieutenant Ralph Johnson flew home with an entire cylinder shot off his engine on August 17th. Captain Walker Mahurin landed with his P-47 resembling Swiss cheese after combat on October 4th, the aircraft requiring 6 weeks of repairs but returning to combat. The 56th Fighter Group's engineering officer, Captain Barney Wazowicz, documented the damage patterns. Most strikes concentrated on engine and cockpit areas where German pilots expected maximum effect. The R2800 engine proved capable of running with up to 3 cylinders completely destroyed. Oil loss could be managed by reducing power and increasing cooling airflow. The turbo supercharger, mounted in the rear fuselage, was protected by the pilot's armour and fuel tanks. Only direct hits with 30mm cannon shells reliably destroyed P-47s, and few German fighters carried such heavy weapons. The mathematics of survival were compelling. By December 1943, the 56th Fighter Group had flown 5,847 combat sorties. Aircraft lost to enemy action, 56. Pilots killed in action, 34. Loss rate per sortie, 0.96%. By comparison, Luftwaffe fighter units operating against American bomber formations suffered loss rates exceeding 15% per mission. The attrition equation was unsustainable for German forces. Technical analysis revealed the sources of P-47 survivability. The R2800 engine's architecture provided inherent redundancy. 2 rows of 9 cylinders each, dual magnetos providing independent ignition. 2 separate oil systems. Even with major damage, partial power remained available. The engine's frontal area, while creating drag, also provided protection for the pilot. Bullets had to penetrate 6 feet of engine before reaching the cockpit. The airframe structure exceeded contemporary standards. Wing spars capable of sustaining 12 G loads. Control cables duplicated with emergency backup systems. Fuel tanks protected by armour plating and self-sealing rubber layers. Ammunition magazines positioned to avoid sympathetic detonation. Every system designed with combat damage in mind. Republic Aviation's production line at Farmingdale, Long Island, manufactured P-47s at unprecedented rates. Peak production reached 16 aircraft per day. Total production would exceed 15,683 aircraft, more than any other American fighter. The industrial mathematics overwhelmed German defensive capabilities. For every P-47 destroyed, 10 more entered combat. Pilot training programs produced qualified aviators faster than combat attrition eliminated them. By spring 1944, P-47 groups had achieved aerial superiority over Western Europe. The kill ratio reached 4.6 to 1 in favour of American pilots. But the true measure of success lay in bomber protection. Before long-range fighter escort, bomber losses exceeded 10% per mission. With P-47 protection, losses dropped below 2%. The mathematical difference represented thousands of aircrew lives saved. Major General William Kepner, commander of the 8th Fighter Command, recognized the P-47's unique contribution. The Thunderbolt proved that survivability was as important as performance. A pilot who knows his aircraft can absorb tremendous punishment fights with greater confidence and aggression. The psychological advantage was incalculable. German assessments confirmed American conclusions. Luftwaffe General Adolf Galland wrote in his post-war memoirs, "The P-47 was a flying tank." Our pilots learned to avoid extended engagements with Thunderbolts unless they possessed overwhelming tactical advantage. The American fighters seemed to violate the laws of physics, continuing to fly with damage that would destroy any German aircraft. The evolution of tactics reflected mechanical realities. Colonel Hubert Zemke developed the Zemke fan formation, exploiting the P-47's survivability to create flexible escort patterns. Instead of maintaining close formation with bombers, P-47s ranged ahead and to the flanks, intercepting German fighters before they reached the bomber stream. The tactic required aircraft capable of sustaining damage during independent operations. Only the P-47 possessed sufficient durability. The Zemke-Fan's effectiveness was demonstrated on February 11, 1944. The 56th Fighter Group, operating independently ahead of the bomber formation, intercepted 60 German fighters assembling for attack. In the resulting combat, P-47s claimed 17 victories against 2 losses. Several damaged Thunderbolts flew home with battle damage that would have destroyed conventional fighters. Lieutenant Roach's aircraft returned with the entire left elevator shot away. Captain Gabreski landed with his engine running on 12 cylinders and the cowling peppered with cannon holes. Francis Gabreski would become the leading American ace in Europe with 28 aerial victories, all scored in P-47s. His aircraft survived multiple incidents of severe battle damage. On November 26, 1943, a 20mm cannon shell exploded in his turbo-supercharger at 30,000 feet. The engine lost all boost pressure. Gabreski glided 80 miles to reach friendly territory, the R2800 engine maintaining just enough power to prevent a forced landing in enemy territory. The ground attack mission revealed another dimension of P-47 survivability. Operating at low altitude against heavily defended targets, Thunderbolts faced concentrated anti-aircraft fire. Light flak, 20mm and 37mm, fired at rates exceeding 120 rounds per minute. Heavy flak, 88mm, created lethal bursts at predetermined altitudes. The mathematics of survival seemed impossible, yet P-47s consistently returned from ground attack missions that would have been suicide for other aircraft. On December 23, 1944, during the Battle of the Bulge, the 56th Fighter Group flew ground support missions in weather that grounded most aircraft. Visibility less than 1 mile. Cloud base at 400 feet. P-47s attacked German armoured columns at minimum altitude. Captain Robert Brooking's aircraft took 87 hits from small arms and automatic weapons. He flew home with cylinders missing, oil streaming from the cowling, and controls barely responding. The aircraft was repaired and flew again 3 days later. The 9th Air Force, specialising in tactical ground support, documented P-47 battle damage statistics. Between June 6, 1944, and May 8, 1945, Thunderbolts flew 135,000 ground attack sorties. Aircraft damaged by enemy fire, 4,293. Aircraft destroyed, 824. Survival rate after sustaining battle damage, 80.8%. No other aircraft matched this survivability rate in the ground attack role. Lieutenant Colonel Kinnard's experience on January 1, 1945, exemplified P-47 resilience. Attacking a German train, his aircraft hit high-tension wires. The propeller blades were bent. The engine cowling was crushed. The oil cooler was destroyed. Kinnard flew 40 miles to base with the engine overheating critically, landing just as it seized completely. The aircraft required an engine change but returned to combat within a week. The cumulative effect on German forces was devastating. P-47s claimed 86,000 railway cars destroyed, 9,000 locomotives, 6,000 armoured vehicles, 68,000 trucks. The transportation infrastructure supporting German forces collapsed, not from precision bombing at high altitude, but from P-47s absorbing ground fire that would have destroyed conventional attack aircraft and pressing home their attacks regardless. The Pacific Theatre provided different challenges but similar results. P-47s operating from bases in the Philippines faced Japanese anti-aircraft fire and fighter opposition. The theatre's vast distances made engine reliability critical. A single engine failure meant ditching in shark-infested waters. Yet P-47s achieved the lowest loss rate of any fighter type in the Pacific. The R2800 engine's reliability, even when damaged, saved countless pilots from water landings. Colonel Neil Kirby, commanding the 348th Fighter Group, demonstrated P-47 combat effectiveness in the Pacific. On October 11, 1943, leading 4 P-47s, he encountered 36 Japanese aircraft. In the ensuing combat, Kirby personally destroyed 6 enemy aircraft. His Thunderbolt absorbed multiple hits from Japanese 7.7mm and 12.7mm machine guns, but continued flying. Kirby would score 22 victories before being shot down on March 5, 1944, when overwhelming numbers finally succeeded where individual combat could not. The Japanese designated the P-47 the Monster for its size and apparent indestructibility. Japanese pilot training manuals emphasized avoiding combat with P-47s unless possessing numerical superiority. The standard Japanese tactic of hitting and running proved ineffective. Brief firing passes failed to inflict sufficient damage. Extended combat exposed Japanese fighters to the P-47's devastating firepower. Production statistics revealed industrial dominance. Republic Aviation's Farmingdale plant covered 2.5 million square feet. Employment peaked at 24,000 workers. The Evansville, Indiana plant added additional capacity. Together, they manufactured more P-47s than Germany produced fighters of all types combined. The mathematical reality was stark. American industrial capacity, combined with aircraft survivability, created an insurmountable advantage. Cost analysis proved equally revealing. A P-47D cost approximately $85,000 in 1944 dollars. A trained pilot represented an investment of $75,000 in training costs. The combination totaled $160,000. If a P-47's survivability saved even one pilot from death or capture, the investment was justified. Over the course of the war, P-47 survivability saved hundreds of pilots who would have been lost in less robust aircraft. The 56th Fighter Group ended the war as the highest-scoring American fighter group in Europe, with 677.5 aerial victories. All achieved with P-47s, despite pressure to convert to P-51 Mustangs. The group's commander, Colonel David Schilling, stated, "We stayed with the Thunderbolt because our pilots trusted it absolutely. They knew that no matter how badly damaged, the P-47 would probably get them home." Individual survival stories accumulated into legend. Lieutenant Quince Brown's P-47 collided with a Focke-Wulf 190 on February 8, 1944. 3 feet of his right wing was torn away. The engine cowling was crushed. The propeller was bent. Brown flew 200 miles to base and landed successfully. The aircraft was repaired and returned to service. The German pilot was killed in the collision. Captain Johnson McGinn survived a direct hit from an 88mm anti-aircraft shell on March 24, 1945. The shell passed through his right wing without detonating, leaving a hole large enough for a man to crawl through. McGinn flew home with the wing flexing visibly with each control input. Republic engineers studied the damage, amazed that the wing structure held. They calculated that any other fighter would have suffered catastrophic structural failure. The technological lessons influenced post-war aircraft design. The A-10 Thunderbolt II, developed in the 1970s, explicitly drew inspiration from P-47 survivability. Redundant hydraulic systems, armor protection for critical components, engines mounted high to avoid ground fire. The design philosophy traced directly to lessons learned from P-47 combat experience. Veterans' accounts consistently emphasized trust in their aircraft. Lieutenant Colonel Robert Baszler, "Flying the P-47, I never worried about the airplane failing me. Engine problems, battle damage, system failures. The Thunderbolt handled them all. That confidence let me focus on fighting rather than worrying about survival." German veterans provided contrasting perspectives. Luftwaffe ace Heinz Bär, with 220 victories. The P-47 was our most frustrating opponent. We would score hits that should destroy any aircraft, watch pieces fly off, see smoke and flames, yet the Thunderbolt would continue flying and often shoot back accurately. It defied our understanding of combat damage. The maintenance perspective proved equally important. Crew Chief Sergeant Anthony Garzino serviced P-47s throughout the European campaign. We'd see Thunderbolts return with damage that seemed impossible. Cylinders shot off, oil lines severed, control cables hanging by threads. We'd work all night, and the plane would fly again next day. The P-47 was designed to be fixed, not just flown. Statistical analysis confirmed anecdotal evidence. The 56th Fighter Group's maintenance records showed 73% of damaged aircraft returned to service within 72 hours. Major structural repairs were completed within 2 weeks. Only complete destruction or loss over enemy territory permanently eliminated aircraft from inventory. This repair rate was unprecedented in combat aviation. The supply chain supporting P-47 operations demonstrated industrial warfare at its peak. Pratt and Whitney produced 125,000 R2-8000 engines during the war. Each engine contained 2,800 individual parts. The supply system delivered engines, spare parts, ammunition, and fuel across global distances. A damaged P-47 in England could receive replacement parts manufactured in Connecticut within 10 days. Ammunition consumption revealed the scale of P-47 operations. Each Thunderbolt carried 3,400 rounds of T-50 caliber ammunition when fully loaded. The 56th Fighter Group alone expended over 10 million rounds during the war. Each round had to be manufactured, shipped, and loaded. The logistical achievement matched the combat success. The human dimension transcended statistics. Behind every survival story was a pilot who lived because his aircraft absorbed punishment that would have killed him in any other fighter. Multiplied across thousands of missions, the P-47's survivability represented thousands of families who welcomed their fathers, sons, and husbands home after the war. Lieutenant Colonel Francis Gabreski, the top-scoring P-47 ace, summarized the aircraft's impact. The P-47 gave us the confidence to engage superior numbers, attack heavily defended targets, and push our attacks home regardless of damage. We knew the Thunderbolt would take care of us if we took care of it. That mutual trust between man and machine won the air war. The final statistics were compelling. 15,683 P-47s manufactured, 3,499 lost to all causes in combat, 746,000 combat sorties flown, 4.6 to 1 aerial kill ratio, 0.7% loss rate per sortie. Behind these numbers lay the fundamental truth. The P-47 Thunderbolt's unprecedented survivability changed the mathematics of aerial warfare. By war's end, German pilots had developed a grudging respect bordering on fear for the P-47. Luftwaffe training documents from early 1945 stated, "Avoid engagement with P-47 formations unless possessing overwhelming numerical superiority and tactical advantage. If engaged, attempt to damage the oil cooling system or turbo supercharger intake. Do not expect single hits to destroy the aircraft." The American Thunderbolt has proven capable of sustaining damage that would destroy any German fighter. The legacy extended beyond combat statistics. The P-47 proved that aircraft design philosophy could prioritize survivability without sacrificing combat effectiveness. Previous fighter designs emphasized performance above all else. The Thunderbolt demonstrated that keeping pilots alive was as important as shooting down enemies. This philosophy would influence military aviation for decades. Test pilot reports from Republic Aviation revealed the engineering decisions behind P-47 survivability. Every component was overbuilt by contemporary standards. Wing spars designed for 12G loads, when 9G was considered adequate. Control cables doubled in thickness. Fuel lines routed through protected channels. engine mounts reinforced to survive crash landings. The weight penalty was accepted as the price of survival. The Thunderbolt's size, initially seen as a disadvantage, proved to be an asset. The large fuselage provided space for armour protection, redundant systems, and structural reinforcement. The massive engine served as frontal armour. The wide-track landing gear enabled safe landings with tyre damage. Every apparent weakness contained hidden strengths. Combat evolved to exploit P-47 advantages, dive attacks from altitude, using the Thunderbolt's exceptional diving speed of over 500 miles per hour. Zoom climbs after attacks, converting speed back to altitude. Head-on passes where the R2800 engine provided protection. These tactics required an aircraft capable of sustaining damage during aggressive manoeuvring. The industrial story paralleled the combat narrative. Republic Aviation transformed from a small company producing 30 aircraft monthly in 1941 to an industrial giant producing 500 monthly by 1944. The workforce expanded from 3,000 to 24,000 employees. Manufacturing techniques evolved to support mass production while maintaining quality standards that pilots' lives depended upon. Quality control at Republic Aviation was legendary. Every engine was test run for 8 hours before installation. Every aircraft was test flown before delivery. Manufacturing defects that might cause combat failures were ruthlessly eliminated. Workers understood that their craftsmanship directly affected pilot survival. Signs throughout the factory reminded employees, "A pilot's life depends on your work." The learning curve was steep but successful. Early P-47Bs suffered from engine problems, radio failures, and canopy malfunctions. Each problem was systematically identified and corrected. By the P-47D model, reliability had improved dramatically. The P-47D-25 and later versions incorporated lessons learned from thousands of combat missions. Survival features were continuously refined based on battle damage analysis. Pilot training evolved to exploit P-47 capabilities. The aircraft's weight and power required different flying techniques than lighter fighters. Energy management became critical. Maintaining speed in combat, using vertical maneuvers rather than horizontal turning battles, trusting the aircraft to absorb damage while pressing attacks. Training programs at bases from Bradley Field, Connecticut to Millville, New Jersey, produced pilots capable of maximizing P-47 advantages. The contrast with German aircraft was stark. The Messerschmitt Bf-109's liquid-cooled engine failed with single coolant system hits. The Focke-Wulf FW-190's BMW 801 radial was more robust but still vulnerable to oil system damage. Neither possessed the armour protection, redundant systems, or structural strength of the P-47. German pilots fought knowing that serious damage meant death or capture. Intelligence assessments confirmed the psychological impact. Intercepted German communications revealed growing pilot reluctance to engage P-47 formations. Luftwaffe morale declined as pilots witnessed seemingly destroyed Thunderbolts continue flying, while their own aircraft fell to single bursts of .50 caliber fire. The term Thunderbolt fever appeared in German medical reports, describing anxiety disorders among pilots assigned to intercept P-47s. The Pacific Theatre provided different validation. Operating over vast ocean distances, engine reliability meant survival. The R2800's ability to run despite damage proved crucial when the nearest friendly base was 500 miles away. Navy pilots flying Grumman F-6F Hellcats and Vought F-4U Corsairs, also powered by R2800 engines, reported similar survivability advantages. Maintenance crews developed remarkable expertise. They repaired damage that seemed irreparable by conventional standards. Cylinder replacements in forward airfields. Control surface reconstruction using salvaged materials. Engine overhauls under combat conditions. The P-47's design facilitated field repairs that would have required factory facilities for other aircraft. The spare parts system was revolutionary. Republic Aviation established part numbering systems that became industry standards. Every component was catalogued, tracked, and distributed based on usage patterns. High-wear items were pre-positioned at forward bases. The result was unprecedented aircraft availability rates exceeding 80%, despite continuous combat operations. Combat photography documented the reality of P-47 survivability. Gun camera footage showed Thunderbolts absorbing streams of cannon fire while maintaining controlled flight. Post-mission photography revealed aircraft that seemed impossible to fly. Wings with gaping holes, fuselages resembling colanders, engines with cylinders blown completely away. Yet these aircraft had returned to base under their own power. The cost-benefit analysis was overwhelmingly positive. A P-47 that survived severe damage saved not only the pilot, but the investment in training and experience. Veteran pilots were irreplaceable assets. Their survival meant continued combat effectiveness. The Luftwaffe's loss of experienced pilots, by contrast, created a downward spiral of declining capability. Weather operations demonstrated another survivability advantage. The P-47's robust construction enabled operations in conditions that grounded other aircraft. Ice accumulation that would destroy lighter aircraft was manageable. Turbulence that would cause structural failure was absorbed. Rain and mud that made operations impossible for German aircraft were routine for Thunderbolts. Night operations, though limited, proved feasible. P-47s equipped with exhaust flame dampeners and basic night-flying instruments conducted intruder missions over German airfields. The aircraft's stability and predictable handling characteristics made it suitable for instrument flight. Several pilots survived night combat damage that would have been fatal in aircraft requiring more precise control. The culmination came during the Rhine crossings of March 1945. P-47s flew continuous ground support missions in the face of desperate German resistance, concentrated flak batteries, emergency Luftwaffe fighter sorties, man-portable anti-aircraft weapons. The Thunderbolts absorbed unprecedented damage while maintaining operational tempo. Not a single Allied unit reported failure of air support due to P-47 losses. Colonel Zemke, reflecting on his command of the 56th Fighter Group, stated, "The P-47 changed the fundamental equation of air combat. Previously, the aircraft with superior performance held advantage. The Thunderbolt proved that survivability could overcome performance disadvantages. Our pilots learned they could accept battle damage that would destroy our enemies and continue fighting. That psychological edge was decisive." The numbers told the story. By May 8, 1945, P-47s had flown more combat sorties than any other American fighter. They had dropped more bombs, fired more rockets, and destroyed more ground targets. Most importantly, they had brought more pilots home alive despite sustaining battle damage that defied conventional understanding of aircraft survivability. German ace Adolf Galland's final assessment was telling. The P-47 was not the best-performing Allied fighter. The Spitfire turned better. The P-51 had longer range. The P-38 had better visibility. But the P-47 was the fighter we feared most because it could not be stopped. Our pilots called it the unbreakable. In the end, that quality proved decisive. The last P-47 combat mission in Europe was flown on May 7, 1945. Appropriately, the aircraft returned with battle damage, 23 bullet holes from German flak. The pilot was uninjured. The aircraft would have flown again if the war had continued. It was a fitting final demonstration of the quality that had stunned German pilots throughout the conflict. The P-47 Thunderbolt's ability to survive everything. The legacy lived on in pilot memoirs, technical manuals, and design philosophies. Every modern military aircraft incorporates lessons learned from P-47 combat experience. Redundant systems, damage tolerance, armor protection, structural overdesign. The principles that saved thousands of Allied pilots continue protecting military aviators today. In the final analysis, the P-47 Thunderbolt represented more than just successful aircraft design. It embodied the American industrial philosophy of overwhelming material superiority combined with innovative engineering. It proved that technology could provide decisive advantage when properly applied. Most importantly, it demonstrated that prioritizing pilot survival was not just humanitarian, but strategically essential. The German pilots who faced P-47s in combat never forgot the experience. In post-war interviews, veteran after veteran described the shock of seeing Thunderbolts absorb damage that would destroy any aircraft in their experience and continue fighting effectively. The psychological impact of facing an apparently indestructible opponent contributed significantly to the Luftwaffe's ultimate defeat. The statistics were staggering, but the human story was more important. Behind every number was a pilot who survived because American engineers had built an aircraft that refused to die. Families reunited, children who grew up with fathers, communities that welcomed home their heroes. The true victory of the P-47 Thunderbolt was measured not in enemy aircraft destroyed, but in American lives saved. The Thunderbolt had proven that in the brutal mathematics of aerial warfare, survivability could be as decisive as firepower or performance. German pilots had been stunned to discover that their opponents flew aircraft that seemed to violate the fundamental laws of aviation physics. The P-47 absorbed punishment that should have been fatal and kept flying, kept fighting, kept bringing its pilots home. That was the legacy of the Republic P-47 Thunderbolt. Not just victory, but survival. Not just air superiority, but the preservation of trained aircrew who would continue fighting until the enemy was defeated. In the skies over Europe and the Pacific, the Thunderbolt had written its legend in armor steel and American determination. It was, quite simply, the fighter that survived everything.